Okay, so now that we know how to do some long division, that's a great tool for us to be able to find the remaining roots. So a couple of theorems. The remainder theorem, it just says that basically if you use long division, you'll be able to tell if you have a root or not. So let's just go through this. And so we're going to use long division. It says A, find the quotient and remainder when p of x is divided by x plus 2. So you know how to long divide. So let's go ahead and do that. And I'm going to save some time by letting you go ahead and do it. I'll start you out. So p of x is 3x to the 5th plus 5x to the 4th minus 4x cubed plus 7x plus 3. And warning, you do not have enough space on this note sheet, so go ahead and do that on another sheet of paper, and I'll come back with you in a minute. Okay, so if you did this correctly, your quotient was 3x to the 4th minus x cubed minus 2x squared plus 4x minus 1, if you can read it right there. And it took a long time, and right here you had a couple of non-like terms that you had to remember not to add together. And then the remainder theorem basically is this. You see the remainder here is 5. Now, when the remainder is not 0, what that means is that this x plus 2 here is not a factor. This x plus 2 is not a factor if the remainder is not 0. Therefore, or additionally, negative 2 is not a root. So if you are seeing if something is a root or not, you can use long division. And if your remainder is not 0, then it's not a factor, and then therefore you don't have a root. So either you made a mistake and you need to go fix your long division, or you can just answer the question, no, it's not a root. That's the important part. However, there is something interesting that happens if we're to evaluate p of negative 2. In other words, if you were to put negative 2 in here, 3 times negative 2 to the 5th plus 5 times negative 2 to the 4th minus 4 times negative 2 cubed plus 7 times negative 2 plus 3. If you were to evaluate all that, and I suggest that you do that, guess what you would get? You would get 5. So that's a really neat way to tell if something is a root or not. If you want to know if negative 2 is a root for this polynomial, just plug it in. And if you don't get 0 right here, then it's not a root. We don't usually use that method, to be honest. We usually just use long division. So if you use long division and you get something other than 0, then it's not a root. Okay, so now we get to the good stuff. So long division is a tool we use. And so you might get some questions like this, and this is all about the factor theorem, and I've mentioned it. It says that if c is a 0, then x minus c is a factor. And this has to be pretty much synonymous. All right, and so the example is let f of a equals 2a cubed plus 5a squared plus a minus 2. And you've got to show that negative 2 is a 0 of f of a. And then find all the remaining zeros. So we can use long division. And so we're going to use the factor theorem, and we're going to say, well, if x equals negative 2 is a 0, that must mean that x plus 2 might be a factor, so I'm going to divide. And I changed the a to an x just to make it a little more clear. So we're going to use long division. And then you know how to use long division. 2x cubed divided by x is 2x squared. 2x squared times x is 2x cubed. 2x squared times 2 is positive 4x squared. Draw your line, change the signs, and you're left with x squared plus x minus 2. And you start over. X squared divided by x is x. Multiply that out. X times x is x squared. X times 2 is positive 2x. Draw your line, change the signs. You're left with negative x minus 2. And then negative x divided by x is negative 1. Multiply that out, and you get negative x minus 2, draw your line, change the sign, and you have a remainder of 0. So that means that negative 2 is a 0 of f of a, or f of x. Now, the second part says find all the remaining zeros of f of a. So we're going to take this quotient right here, and we're going to set it equal to 0. And you can use either method to solve that quadratic. You can use the quadratic formula, or you can use factoring. So I'm going to show you how to use the quadratic formula on this one. And so x equals negative b, which would be negative 1, plus or minus the square root of 1 squared, which is 1, minus 4 times a, which is 2, times c, which is negative 1, all over 2 times a, which is 2. And that gives you negative 1 plus or minus the square root of positive 9 over 4. That gives you negative 1 plus or minus 3 over 4. What that means is that x is equal to negative 1 plus 3 over 4, or x is equal to negative 1 minus 3 over 4, and that gives you 2/4 or 1/2, or negative 4 over 4, or negative 1. So the remaining roots are 1/2 and negative 1. And then you can also make the connection. You see how this started out as a degree 3 right here, and you have 3 roots. You have the negative 2 that you started with, and then you have 2 more. So all the roots are negative 2, 1/2, and negative 3. That's 3 roots. The degree was 3. That's always going to happen if you include multiplicity. Notice also that since your roots came out to be nice and rational, that tells me you could have factored. You could have factored this and gotten the right answer, but the quadratic formula works all the time as well. Okay, so that's it. We'll do another one, and this time I've got the steps written out for you. And if you're asked to find all real exact roots of polynomials, step 1, if necessary, find the factor associated with the given root. If the root has a multiplicity of 2, then you're going to write the linear factor twice and multiply it out. So I'll do an example in a minute of that. And then use long division to reduce the polynomial to a degree 2 quadratic function. And then set that quadratic equal to 0 and solve by factoring or the quadratic formula. So the second example that I'm going to do is number 1 here. Show that 2 is a root of p of x and find the remaining roots. So I'm going to write that out, and you do the same, and then hit play. We'll continue. Okay, so I did that. I have 2 as a root, so that means that x minus 2 is a factor. So I'm going to use long division, and I'm going to divide x minus 2 into that polynomial and get the quotient. You might want to hit pause and do it, and I'll come back with the answer. So if you did this right, you should have gotten x squared, and then x squared times x is x cubed, and x squared times negative 2 is negative 2x squared. And then you have x squared minus 14x plus 24. Now you're going to distribute x squared times x. You're going to divide again. So x squared divided by x is x. And then multiply it back out, distribute. You get x squared minus 2x. Draw your line, change the sign. That's going to give you negative 12x plus 24. And then you're going to divide again. Negative 12x divided by x is negative 12. Then you're going to multiply by distributing. You get negative 12x plus 24. Draw a line, change the sign, and you get a remainder of 0. And that tells me for sure that x minus 2 is a factor, and it tells me for sure that 2 is a root. So now it's time to find the remaining roots. So I'm going to take the quotient here, x squared plus x minus 12 equals 0. And this time I'm not going to use the quadratic formula because this factors really easily into x plus 4, x minus 3. So that means that x equals negative 4 or x equals 3 are your remaining roots. So our roots are 2, negative 4, and 3. There's 3 roots. The degree of the polynomial is 3, not a coincidence. So the next 2 examples are pretty much the same thing. So we want to show that x minus 3 is a root. So that means that x plus 3 will divide into 2x cubed plus x squared minus 13x plus 6. So that's going to be 2x squared, then multiply it out, and you get negative 5x squared minus 13x plus 6. Time to divide again, negative 5x, and then distribute. That gives you negative 5x squared minus 15x. Draw your line, change the sign. That gives you 2x plus 6. Time to divide again. 2x divided by x is positive 2. Multiply it out, 2x plus 6. If you subtract, you're going to get a remainder of 0. So that's what we would expect. X plus 3 is a factor, negative 3 is a root, and we're going to use the quadratic formula this time to find the remaining roots. If you're good at factoring, you could try to factor this. I'm going to use the quadratic formula and get 5 plus or minus the square root of 25 minus 4 times 2 all over 2 times 2. X equals 5 plus or minus the square root of 25 minus 16, which is 9, over 4. X equals 5 plus or minus 3 over 4. So our roots are this original negative 3 from up here. Then you have 5 plus 3 over 4 is 2, and 5 minus 3 over 4 is 1/2. So those are all the roots. Okay, next one I'll go through with you. This one's just to show you that sometimes they don't come out to be nice rational roots. So this one, you're going to divide by the factor that's associated with 3, which would be x minus 3. And if we divide it into this polynomial, and again, you can pause and do this on your own. I'm kind of going to go through it fast. And you end up with 2x squared. Draw your line, change the sign. You get negative 5x squared plus 7x plus 24. And then divide again. Negative 5x squared divided by x is negative 5x. Then you distribute. Negative 5x squared plus 15x. Draw your line, change the sign, and you get negative 8x plus 24. Divide again. You get minus 8. Multiply out, minus 8x plus 24. If you draw your line, change the sign, you get a remainder of 0. So we now need to use the quadratic formula, taking that quotient, 2x squared minus 5x minus 8 equals 0. This is what we do to find the remaining zeros. That's going to give us x equals 5 plus or minus the square root of 25 minus 4 times 2 times negative 8 all over 2 times 2. And that is going to give us x equals 5 plus or minus the square root of, and this gives us 25 plus 64, which is 89. And 89 you'd have to check, but 89 doesn't break down to any perfect squares. So this is a case where our roots are, if we take the original root, 3, you have 5 plus the square root of 89 all over 4, and 5 minus the square root of 89 all over 4 as your two other roots. So you're not always going to get nice rational roots. If you were to multiply that out or add, just take the square root, you get decimals, and you can have decimals as your roots. But we want to leave it exact, so we would leave the radical in the final answer. Okay, last type, we're not done yet. So this is, what if your multiplicity is not 1? So example 4 says find all real exact roots for p of x if -4 is a root with multiplicity 2. Okay, so you have an extra step that you want to do here. If -4 is a root, then that means that x plus 4 is a factor, and if it's multiplicity 2, then you have a square there. So what you have to do before you can divide is you have to multiply this out. And again, we know how to do that quickly. X plus 4 quantity squared is x squared plus 8x plus 16. So that would be your initial step. And then once you have that, now you can use line division. So x squared plus 8x plus 16 into x to the 4th plus 3x cubed minus 36x squared minus 176x minus 192 is going to be, so x to the 4th divided by x squared is x squared. Then you have to multiply all that out. So that's x to the 4th plus 8x cubed plus 16x squared. Draw your line, and you're going to subtract. So I like to go ahead and distribute the negative. So that gives you -5x cubed minus 52x squared, and then bring those two down, minus 176x minus 192. Now it's time to start over. -5x cubed divided by x squared is -5x. Now it's time to distribute, and you get -5x cubed minus 40x minus 80x. Excuse me, I lost a square here, so it should be minus 40x squared, then minus 80x. And then you're going to draw your line, change the signs. They cancel, and you have a -12x squared, and then minus 96x minus 192. Divide again. -12x squared divided by x squared is -12. And then you're going to distribute. That's going to give you -12x squared. And then -12 times positive 8x is -96x. And then -12 times positive 16 is -192. And it turns out your remainder is 0. Okay, so then it's like before. You can take the quotient here, and you're going to find the remaining roots by setting that equal to 0. So that's x squared minus 5x minus 12. And I can tell it won't factor, so I'm not going to be surprised that I'm going to get some irrational roots, but I can use the quadratic formula. So that's going to be 5 plus or minus the square root of 25 minus 4 times 1 times -12 all over 2 times 1. So x equals 5 plus or minus 48, positive 48, plus 25 is 93, square root of 93. And so 93 doesn't break down. So our other two roots are these guys. These are the other roots. And again, we can check it. See how the degree was 4? This -4 is a root, but it's got a multiplicity of 2, so it counts twice. So you have 1, 2, 3, 4 roots. The degree is 4, and that's always going to be true. Okay, the number 5 you should try on your own. I'm going to pause it, do all the work, and then play it, and I'll show you the answers. Okay, I'm going to pick it up here. First thing you should have done is change this 3, that's a root, to its factor, which was x minus 3. Its multiplicity is 2, so you should have squared that. Got x squared minus 6x plus 9. Divided, and gotten the quotient 3x squared plus, minus 4x minus 3. Set that equal to 0. Use the quadratic formula, And you should get x equals 4 plus or minus the square root of 52 over 6, but I wanted to pick it up here to practice this with you. 52 is 2 times 26. 26 is 2 times 13. So the square root of 52 is 2 times 2 times 13. So that means you can pull out a 2. So x equals 4 plus or minus 2 square root of 13. It takes 2 to pull out 1. All of that is over 6. So that means since the coefficients of 4, 2, and 6 have a 2 in common, you need to divide that out. So that means that your final roots, reduced roots, are x equals 4 divided by 2 is 2, plus or minus 2 root 13 divided by 2 is just root 13, and 6 divided by 2 is 3. So these are your two remaining roots. The remaining roots. We wanted to talk about all the roots. We would include 3 as well. Okay, so last one. So you're given a factor. So I didn't give you the root. I've already given you a factor. So I'm saving you a step. And you just divide x squared minus 4 into x to the 4th minus 20x squared plus 64. There's some terms missing, so be careful. And you have x to the 4th divided by x squared, which is x squared. Multiply that out and you get x to the 4th minus 4x squared. Draw your line, change the sign. Oh, it turns out that they're both missing the same term, so you've got like terms lined up here. You get negative 16x squared plus 64, and then you start over. So negative 16x squared divided by x squared is negative 16, and that gives you negative 16x squared plus 64. Draw your line, change the signs, you get a remainder of 0. Set x squared minus 16 equal to 0. I would not use the quadratic formula here. This is a difference of two squares. It factors into x plus 4 times x minus 4, because 4 times 4 gives me 16. So you have remaining roots of negative 4 or 4.